Hello, IB Environmental students. Today we're going to be doing Google Sheets. This is the required video that tells you the basics, and it's based on a water quality example. We're going to jump right in so we save time. This follows the individual graphing workbook. All right, please make sure you're practicing on your screen too. What we see here is an example raw data table where the inside, the DV, is nitrate levels in mg per L, and the IV says it's samples along Pohick Creek watershed. Notice that this is a qualitative IV. These are not numerical distances along the creek. All right, we can see that there's 5 different levels and 5 different trials for a total of 25 different samples. We see that this table title is strong because it's numbered, has units, is very specific, and has measurement uncertainty, which is half of the precision or significant last digit here. All right, 1 decimal place here, then we divide by 2 at the last decimal to get a 0.05 for the nitrate probe's uncertainty. Now what we're really interested in today is, well, how can we take a table that we're adding into Sheets, that's a raw table, and how can we then make a process calculated data table that's organized that will then help us make a really nice chart or graph. So if we scroll down, right, we can move down and we can talk about how this will work. Very basic stuff to understand is that if I click on one of these boxes, that's called a cell. So I clicked on the one that's distilled water average. All right, so this is the process data table number 2. It says that averages were for n equals 5 trials. There were 5 trials. And it also shows a standard deviation row. And what we see here is if I clicked on distilled water average, I can refer to this box or cell by calling it B22. Why? Because it's in the B column in the 22 row, right? Just like Battleship. So as we talk about cells, they'll have a number and a letter. So what we're going to learn here is that to do a calculation or process a type of data, we're going to do an equation in Sheets. And to do an equation, I'm going to have to click on a cell, and I'll have to use the function bar. Since I already made this for you, the function's already there, which is cool because it gives you really nice examples. Functions will always start with an equal sign. They will have the title of the function. In this case, we're calculating in this row average. So it says average. And they will always then have a parentheses. In the parentheses, we will have the column letter, its number, through another the same column, or it could be a different column, and another number. That inner part with a semicolon in between tells us what section are we actually doing the averaging for. All right, and let's see if this makes sense. For distilled water here, for B22, we want an average of B9 through B13, and that's what it says. We're going to practice by actually going to the next one over headwaters, and we're going to see that it says 1.8. We're going to delete it, and we're actually going to delete all the other ones. And we're going to see if we can recalculate them and get the same ones as before. So now I'm clicking on C column, row 22. I'm going up to the function. I'm clicking an equal sign. The type of function I'm doing is average, and as I start to type it, we can see that Sheets knows what I want. When I click on the thing that it thinks I want, it'll put a parentheses, and to tell it that I want to do this first cell, C9, I could either type C9, but I find it easier to actually click on C9 and actually then drag my cursor down while still clicking through the section I want to actually average. When I'm done, I can then click on parentheses and end it. And when I click enter, I get the same average I had before. So instead of having to do that boring typing into your calculator, now I can do it in a really organized way and also have my nice digital table. Super nice. Let's do it one more time for the midstream. I click on the midstream box or cell. I go up to the function. I click equal sign, average. I click on the first midstream cell. I scroll or drag my cursor down. I end my parentheses. Double check that was the right section. Press enter. and I get the right thing. Now I'm going to teach you a super secret ninja move. All of the pattern was the same for this whole row. It was always doing one of these columns, the 9th row through the 13th row. Because that pattern will stick true also for downstream and Pohik Bay, it'll just be for this column and then this column. I can tell Sheets really fast to do the same thing. By clicking on the box with the equation already made in it, I can say, hey, do the same pattern. And I can say that by clicking this little blue square, and when this plus symbol comes, I can drag the cursor to the right over those other two things I want to calculate and say, hey, do the same calculation, same pattern. And look, it does it. And if I want to double check that it's doing it right, I can click on, for instance, this last one and check, is it highlighting the right section to do averaging? And it is. Awesome. I saved myself a whole bunch of time. So that's averaging. Next, we want to do standard deviation or the spread. Standard deviation, if we look at this raw table, should be really low because they're very much not spread out across one of these levels of IV. There's not a lot of differences between 1.7, 1.8, and 1.9. So it makes sense that these standard deviations are low. It's unusual for all the standard deviations to be the same. That's just this example. So if I click on this B23 cell, I can see that there's pre-made a standard deviation equation. It follows a very similar format to the average equation, where it starts with an equal sign, then has the equation name, parentheses within the middle saying what trials am I doing the calculation on. I'm going to delete the following ones: headwaters, midstream, downstream, and Pohik Bay to do the calculations for them too. So I'm going to click on headwaters. I'm going to practice by saying equal sign STD, and then it already knows standard deviation was the thing I was beginning to type. For headwaters, I want to select the headwaters trials by clicking on them and dragging down, ending my parentheses, and clicking enter, and it does the calculation. Let's try it one more time for the midstream. I go starting with an equal sign because it's an equation. I start typing standard deviation. It knows what I want. I then click the first part of the midstream I want to do the equation on. I drag down to highlight the whole section I want to do it on. I then end the parentheses, and then it works. Notice that it's the same type of pattern that I did for the averages, where it's always the 9th row through the 13th row. So if I click on this cell, I can say, hey, Sheets, use the same pattern. I'm a ninja at this already. I can click on that little blue box at the bottom right with my kind of plus sign cursor and drag across, and it'll do the calculation all the way through to the right. Awesome! So that's how we do this nice standard deviation averaging on Sheets. Now, I've organized this to look all pretty with borders, which is this symbol, and filling colors and bolding. That's something you can do if there's extra time, but you don't need to worry about that now when you try to make your own. The next thing we're going to be scrolling down to work on is trying to recreate the bottom graph, all right? Or as Sheets calls it, a chart. This bottom chart is a bar graph. Why did we pick a bar graph? Well, again, we have a quantitative average, or DV, for nitrates, but we have a qualitative word description, IV. If this had been quantitative distances along the creek, we would have been able to do a scatter plot. However, because it's not quantitative, we must do a bar graph. All right, notice that my bar graph has a lot of really important things we're going to be recreating. Has axes labels. We're going to even improve them. It has error bars, and it has the correct thing on the correct axis. The IV's on the x-axis and the DV's on the y-axis. All right, notice if I scroll all the way down here, I can see the figure title is actually not on the actual graph. I could always type this into a Google Doc itself. The figure title is just as descriptive, if not even more descriptive, than a table title. It says that this is averages. I did not graph the standard deviation. I do not graph the raw data. It also shows me uncertainty, and it tells me the error bars I selected were the average standard deviation, because on sheets you can only pick one value to use across all of the series of data, and the average in this case was 0.1 milligrams per liter. Now let's try to recreate the graph. As I do this, I need you to practice trying to do it yourself too, because it's a little difficult and you're going to have to do it on these other harder sheets. So when I graph, I select all the IV in that row and all the DV in the row below it. Notice that when I select it, it highlights it. I didn't highlight the word average, the word standard deviation, or the standard deviations. I'll do it one more time for you. I highlighted distilled water through Pohick Bay down through the actual average values. I'm going to go to Insert, Chart. Now as I do this, note that I am smarter than Sheets and so are you. You're going to have to look at this chart that it tries to create for you, and you're going to have to make a good, knowledgeable thinking reasons about is it doing it right. So sometimes it actually will flip the IV and the DV. If it does that, I can click on this option under Data, or on the Data thing, and I can say Switch Rows and Columns. That says switch where the IV and the DV are. This is actually worse looking. Now my DV's on my X, and I needed it to be on my Y-axis. Ah, that's better. It was better to begin with, so I re-clicked it. Alright? Now, other things we're going to do. We're going to remember that our figure title is actually typed underneath on Google Docs or Google Sheets. I'm going to delete this title because it's too bulky. I clicked on it and then I deleted it, and that'll actually make it go away. This also took me from this Data tab over to Customize. I'm going to also, I can do weird cool styles to my chart. That's just for fun. But we're focused on actually adding the axes labels to the horizontal and the vertical axis, and that's under axis titles. So if I wanted to add a chart title back, which I don't, I could go here, but let's add a horizontal axis. The horizontal axis was locations along Pohick Creek watershed, and that makes that come up there. I click again over to vertical axis to switch it to that. Now average could have been average elephants, so we need to be more specific than that. Nitrates with the units. Alright. I can say how many trials. N equals 5 trials. I should say also my uncertainty on the probe. My uncertainty was plus or minus 0.5 milligrams per liter on the probe. That's a very nice and specific axes title. Now I'm going to click away from this. Notice I could change it to be all pretty. I don't care about that right now. The next really important thing is I want to get rid of my legend. I don't need a legend in this situation. So I go to legend and I click none. Other things might need a legend. It depends on your data set. My last important things are under series. Under series, this is where I find error bars. It's also where I find line of best fit and data labels. We're actually going to add data labels where it's going to add in the actual average values. The last thing we're going to do is we're going to add error bars. Now, if I remember my figure title, it told me I selected that the error bars would be the average of the standard deviation. Error bars you're going to have to make your best decision on. The default is usually percent and 10% of whatever the value here is. So this says 2.6. It's doing 10% of 2.6. Here 10% of that. So it's changing. I don't tend to love that. So I tend to recommend a constant. And a constant being maybe the measurement uncertainty, which would have been 0.05 on the probe. But that's pretty small, and we don't want to be too small. So instead I selected the average of the standard deviations, which was 0.1. And that's how I got my error bars. Because of that, it made it so that we had a negative, and that doesn't make a ton of sense. So I can go back to chart and axes titles, and in here, oops, actually I can go to vertical axis instead, sorry about that. Somewhere in here I can set a minimum and max, so I went to vertical axis. I don't need a minimum below 0, so I'm going to set please don't go below 0. That doesn't really make sense to have negative nitrate levels. And that's it. That was pretty hard, but you know what? It just takes time and practice. Great job, guys.